Hi everyone. By the end of this video, you will have a clear idea on equations of motion. We call it as SUVAT, S-U-V-A-T. Equations, how to derive equations of motion graphically. Then as usual, some MCQs, some ARQs and some numericals. Let's see the main equations of motion. The first equation is simple way, V equals U plus AT. Second equation is S equals UT plus half AT square. Third equation is V square equals U square plus 2AS, where S stands for displacement, which is in meter, T stands for time in second, U stands for initial velocity, V stands for final velocity, both in meter per second, and A stands for acceleration. Among them, all are vectors except T. So, we may choose displacement positive or negative, U positive or negative, V positive or negative, A positive or negative. And there is one more equation, S equals U plus V divided by 2 times T. So overall, there are 4 equations. We need to derive the first equation. For that, we need velocity time graph. From the graph, it's clear. Starting velocity U, we choose it as V0. Final velocity, we choose it as V. Starting time 0 and final time T. And we know acceleration is slope of velocity time graph, which is rise over run. Rise means this height, which is V take away V0. Run means this distance, which is T take away 0. And acceleration, rise over run, V take away V0 divided by T. Take T to the other side, AT equals V minus V0. Make V the subject, so it is V0 plus AT. Simple format, V equals U plus AT. Derivation of second equation. For that also, same graph, and we are looking for x, which is displacement. By the rule, displacement is area under the graph, and the area under the graph, you can see it's divided into a rectangle and a triangle. So add the two areas together. Area of the rectangle is width times length. Then area of triangle is half times base times height. Width is T and length is V0. So area of rectangle is V0 times T, and area of triangle half times base times height. Half base is again T. The height is V take away V0. We knew V minus V0 is AT. So plugging in place of V minus V0, just replace it by AT. Eventually the equation becomes x equals V0t plus half AT square. Simple format, S equals UT plus half A square. The third equation, we wanted displacement. Same as before, displacement is area under the graph. Here, we just go for area of trapezium. And the formula for area of trapezium is half one of the two parallel sides, A, the other parallel side, B, times the height between the two, which means the distance between the two parallel sides. And you can see from here, half one of the sides is V0. The other side is V, so V0 plus V, and the distance between the two is just T. That's it. Done. In simple format, S equals U plus V divided by 2 times T. Eventually, this is the average velocity of two velocities times time. We move on to the fourth equation. To derive the fourth equation, we start with the first equation, V equals V0 plus AT, squaring on both sides, math. When you square on both sides, left side it will be V square, right side will be A plus B the whole square. So V0 square 2 V0 AT and then A square T square. What am I going to do next is I want to take 2A outside. So I just rewrote like this. Here I multiplied by 2 divided by 2. So I'm writing V0 square first. Then I'm taking 2A out. What is remaining there? V0 T. Plus, if I take A out, what is remaining? Half A T square. Why did do? Reason is simple, because this is equal to our displacement x. So replacing the one in blue with x, we are done. In simple format, we can write it as V square equals U square plus 2AS. We will do some MCQs. First MCQ, the kinematic equations, what we did before, all the 4 equations is applicable when acceleration is constant, which means uniformly accelerated motion. Second one, distance covered by a moving body is directly proportional to square of its time, then the acceleration of the body is again constant. Why is it so? We can write s equals ut plus half at square. When starting speed is 0, this disappears. You can see here s depends on t square, which means s is directly proportional to square of the time when acceleration is constant. We do some ARQs. The first ARQ, the kinematic equations, which is given, I am leaving it, can be applied to calculate the trajectory of an object moving continuously changing acceleration. No, acceleration has to be constant. So assertion is false. And let's see the reason. The equations of motion are strictly derived under assumption that acceleration is constant. That is true. So assertion is wrong. Reason is true. So the answer is D. Stopping distance of a moving vehicle with constant decelerating force, which means constant deceleration, is directly proportional to square of its initial velocity. Let's see this equation. Stopping means this becomes 0. Then that equation becomes 0 equals u square plus 2as. Rewriting u square minus u square equals 2as. What do you see here? S depends on u square. Stopping distance depends on square of the initial speed. That is what they say in the second statement. So reason is true, assertion is also true, and they are the best choices for each other. So choice A. Moving on to another one. A body is released from rest, falls through distances in the ratio of 1:3:5:7 in successive time intervals. That is true physics. For a freely falling body dropped from rest, the displacement in any second, maybe first second, second second, third second, is given by this equation. This is also true, and this is the reason for that. So the answer is A. We move on to numericals. Numerical number 1. The question says a car travels with a speed of 108 km per hour. We have to change the kilometer per hour into meter per second. How do we change kilometer per hour into meter per second? Times 5/18. So the starting speed is 30 meter per second. And it says provided by a uniform deceleration, which means acceleration is -5 meter per second square. And they wanted the distance travel before the car stops. The car stops means the final speed has to be 0. And we want s. So we go for an equation without t, which is v square minus u square equals 2as. Plugging the number, v is 0, 0 square, u is 30, so 30 square, 2 times a minus 5 times s. Left hand side is minus 900, right hand side is minus 10s. Moving minus 10 to the other side, so it becomes divided by minus 10, so 90 meter. Displacement is 90 meter, which means the car stops after 90 meter. And second part, how much time the car takes to stop. So we go for simple equation, v equals u plus at. V is 0, u 30, a minus 5, t. Taking minus 5 to the other side, it becomes plus 5t equals 30 divided by 5. So t equals 30 divided by 5, which is 6 seconds. Numerical number 2. A ball is thrown vertically upwards with a velocity of 20 meter per second. Anything upwards, since it is a vector, has to be taken as positive. So initial velocity is plus 20. Why plus? It's upwards. How high? From the ground, the ball rises. At the highest point, we know the ball will have a speed 0. And we know acceleration is always acting downwards. Why? Gravity is pulling the ball down. Even though the ball is going up, gravity pulls down. So acceleration due to gravity, being a vector, has to be negative to show that it is downwards. How high does it go? So we look for displacement. An equation without t, which is v square minus u square equals 2as. Plugging the numbers, v is 0, u is 20, so 20 square. 2 times a minus 10 times s. Left hand side is minus 400. RHS is minus 20s. Move minus 20 to the other side, so it becomes minus 400 divided by minus 20. The final answer is 20 meter. So the ball goes to a height of 20 meter from the top of a building. So how high from the ground the ball travels? 25 meter already, the top of the building, plus the extra 20 it has traveled. So final answer becomes 45 meter. And the next part, how much time it takes? Simple formula, V equals U plus AT. We know V is equal to 0, U is 20, A is minus 10, taking minus 10t to the other side. 10t is equal to 20. So t is equal to 20 divided by 10, which gives you 2 seconds. Numerical number 3. Same question, but something else they are asking. Moving on to numerical number 3. The question says the starting velocity of the ball is 20 meter per second in the upward direction. So u equals plus 20. Why is it plus upwards? It is thrown from a height of 25 meter and they wanted how fast the ball hits the ground. So let me draw the building. This is the building. The building has a height of 25 meter. You throw the ball from here. The ball goes all the way up and comes back and falls here. This is the starting point. This is the final point. And we know displacement is a straight line from starting point till the ending point. Look at the arrow from top to bottom. How much is the displacement? 25 meter. What is the direction? Downwards. So displacement is minus 25 meter. They wanted how fast it hits the floor. So we go for an equation which doesn't contain t, which is v square minus u square equals 2as. Plugging the number, we do not know. So v square, u is 20, so 20 square. 2 times a as before. Acceleration is downwards minus 10 and s is minus 25. Mathematics. The LHS becomes v square minus 400 minus 20 times minus 25, which gives you 500. Moving minus 400 to the other side, it becomes plus 400. So v square is 900. So v equals root of 900, which is plus or minus 30. We go for the negative sign, which means the ball is hitting the floor in the downward direction. The second part, they wanted time. Simple formula. V equals U plus AT. How much is the hitting speed? Minus 30. How much is the starting speed? Plus 20. Acceleration is minus 10. Moving 20 to the other side. Left hand side becomes minus 50 equals minus 10. Moving minus 10 to the other side. It becomes divided by minus 10. So minus 50 divided by minus 10 gives you 5 seconds. Numerical number 4. A hot air balloon is moving up. Along with the balloon, the stone is also moving up. So starting speed of the stone is 10 meter per second upwards. So plus 10. And the acceleration is acting downwards, minus 10. And the stone is dropped from when it was at a height of 40 meter. The stone goes all the way up and comes back. Displacement is straight line joining the two. How high was the balloon? 40 meter. So displacement is 40 meter, but downwards. So minus 40. And what do they wanted? They wanted the time taken. Go for the formula. S equals ut plus half at square, which doesn't contain v. Plugging the numbers, S is minus 40. U is 10 times t. Half A is minus 10 t square. Minus 40 equals 10t minus 5t square. Moving all of them to one side, it becomes 5t square minus 10t minus 40 equals 0, which is a quadratic equation. Dividing all the terms by 5, so it gives you t square minus 2t minus 8 equals 0. Factorization, we know we have to look for a term where the product is minus 8 and the sum is minus 2. So the two terms are minus 4 and plus 2. The product is minus 8 and the sum is minus 2, which means t can be 4 seconds or t can be minus 2. Minus time is not possible because time is a scalar, so negative number is not possible. So time equals 4 seconds. Numerical number 5. A stone is dropped from rest into a deep well. The sound of splash is heard exactly 3 seconds later. Here we have two situations. Stone is moving down and the sound is coming up. So we deal them separately. And they gave you speed of the sound and they wanted time taken by the stone to reach to the top of the water surface, and they wanted depth of the well. G is given as 10 meter per second square. We assume that the time taken by the stone to reach the water surface is t. So stone takes t seconds to reach to the surface of the water. The sound takes remaining time. How much is the total time? 3 seconds. So remaining time is 3 minus t is the time taken by the splash sound to reach to the top. So first let's go for the stone. And we know we are looking for distance traveled by the stone. U is given 0. A, since it is falling under gravity, minus 10 meter per second square. And time taken, we assumed it as t for the stone. Which equation are we going to use? S equals ut plus half a t square. Plugging the numbers, we don't know s. Starting speed is 0, so this becomes 0. Half times minus 10 times t square, which gives you s as minus 5 t square. Minus shows it's moving downwards. So total distance traveled by the stone is 5 t square. We have two unknowns, s and t. So we need another equation which we are going to do with sound. Since sound travels with constant speed, we can use simple equation. Distance traveled by the sound is speed times time. Speed of the sound is given as 340. Time taken by the sound is 3 minus t, which gives you s as 1020 minus 340 t. We knew these two are equal, so 5t square, distance traveled by the piece of rock, should be equal to the distance traveled by the sound. So we are equating those two. And when we rearrange them, we get a quadratic equation. And we can see 5 is common everywhere. So dividing by 5 everywhere, which gives you t square plus 6t minus 204 equals 0. Quadratic equation. Solving the quadratic equation, plugging the numbers, a value is 1, b value is 68, c value is minus 204. Plugging them in the equation to solve quadratic equation, we get two values for time. One value is negative, which I throw away. Time cannot be negative. We get the time as 2.88 seconds. First part over. This much time the stone takes to reach to the water surface. And to get the depth of water, we have to plug the time in one of the two equations, either 5t square or the other one. Simple one, plug this in 5t square. 5 times time is 2.88 square, which gives you 41 meters. So depth of the well is 41 meter. Tricky question. Numerical number 6. A ball is dropped from a top of a tower of height 19.6. At the same time, another ball is thrown from the ground with a velocity of 10 meter per second upwards. When and where they are going to meet? We choose G as 9.8 meter per second. For that, we assume the two balls meet after t seconds. Here we have two situations for ball number 1 and for ball number 2. So we choose for ball number 1, starting speed is 0. A is minus 9.8. S we do not know. T we assumed time as just t. So we make an equation in terms of all these. S equals ut plus half a t square. Plugging the numbers, S is u, 0, disappears half. A is minus 9.8, then t square. We get S as minus 4.9 t square. Negative sign shows that the first ball went down. So the distance is just without the negative sign, scalar 4.9 t square. For the second ball, starting speed is 10 meter per second upwards, so plus 10 meter per second. Acceleration same, always downwards, minus 9.8. Time, same time. Using the same equation, plugging the numbers, we get S equals 10t minus 4.9 t square. These two distances together make the total distance. Why? One ball went down and the other ball went up. How much is the total height of the building? 19.6. So S1 plus S2 gives you together 19.6. S1 is 4.9 t square. S2 is 10t minus 4.9 t square. Adding them together gives you the total distance, which is 19.6. Minus 4.9 t square plus 4.9 t square cancels. Remaining one is 10t. So t equals 19.6 divided by 10, which gives you 1.96 seconds. And to get the meeting height, plug this t in one of the two equations. Let's plug in this because this is the height. This is the distance through which it is falling down. First ball was falling down and second ball was going up. So to get the meeting height, we have to plug in this equation. The t value 1.96. Plugging that gives you the final answer 0.78 meter. So the two balls meet at a height of 0.78 meter after a time of 1.96 seconds. Numerical number 7. Bullet strikes a uniform plank with a velocity of 400 meter per second and comes out with a final velocity 200 meter per second. What would be the velocity with which the bullet comes out if the plank was only half of the thickness? For that, we assume x be the thickness of the wooden plank. There are two situations. Case number 1, the starting speed of the bullet is 400 meter per second. The bullet comes out with a speed of 200 meter per second. We do not know how much is the acceleration, but we know the size of the plank is x. There are two unknowns, x and a. We need two equations and we have two situations. The equation we use over here is v square minus u square equals 2as. Time is not given, so an equation without t. Plugging the numbers, v square is 200 square, u is 400 square, 2 times a times s is x, which gives you 40,000, take away 160,000 equals 2ax, which gives you minus 120,000 equals 2ax. Dividing both sides by 2, we get it as 60,000 equals ax. Leave it. This is from the first situation. For the second situation, starting speed is same 400, but the size of the plank became half of the size, so s becomes x by 2, and we wanted to calculate how much is v. We have no idea about a. Same similar equation we use, and plugging over there, we do not know how much is the final speed. Starting speed is 400. 2a, how much is size x by 2? 2 cancels. We get v square minus 400 square equals ax. V square minus 400 square. In place of ax, I can write it as minus 60,000. V square, taking this to the other side, which becomes plus 400 square minus 60,000. Calculator. 160,000 take away 60,000 v square, which gives you 10,000. So v will be square root of 10,000, which is 316 meter per second. So the bullet comes out with a speed of 316 meter per second. Moving on to numerical number 8. It says a body is thrown up with a velocity 10 meter per second. After 1 second, another body is again thrown up with a velocity 20 meter per second. And when and where do they meet? Take g as 10. So we assume they meet after t seconds, after the first ball has thrown. There are two cases. So let's focus on ball number 1. The ball number 1 is thrown up with 10 meter per second. So starting speed is 10, upwards positive. Always acceleration is negative. It's taken as 10. And we wanted to find s. We assumed the time taken is t. We go for the equation without v, which is s equals ut plus half a t square. Plugging the numbers. S, no idea. U, 10 times t, half a minus 10 times t square, which gives you 10t minus 5t square. Distance traveled by the first ball in the upward direction, 10t minus 5t square. Moving on to the second ball. Starting speed of the second ball is 20 meter per second, upwards, so plus 20. Acceleration same, downwards always minus 10. S we have to find, and how much time it takes. 1 second later. First one travels a total time of t seconds before they meet. So second ball travels 1 second less than the first ball. So it is t minus 1. Plugging the same in the same equation, s equals ut. U is 20. T, here it is t minus 1. Half a minus 10. T minus 1, the whole square. Physics over math. 20 times t, 20t. 20 times 1, minus 20. Half times minus 10 gives you minus 5. So minus 5 times t minus 1, the whole square becomes t square minus 2t plus 1. Taking minus 5 inside, that gives you 20t minus 20. Then 5t square minus 5 minus 2 becomes plus 10t, and final value minus 5. So the height traveled by the second ball is 20t, and 10t gives you 30t, and minus 20 and minus 5 gives you minus 25 and minus 5t square. We know these two heights are the same, so we can equate these two heights. What is the first height? 10t minus 5t square equals the distance traveled by the second ball. The second height is 30t minus 25 minus 5t square. Minus 5t square minus 5t square cancels. I take minus 25 to the other side. It becomes plus 25. 10t I am taking to this side, becomes minus 10t. So 30t minus 10t gives you 20t. So t equals 25 divided by 20, which gives you 1.25 seconds. So the two balls meet after a time of 1.25 seconds. Where do they meet? We have to find the height. Choose one of the distances. So I go for the first distance, 10t minus 5t square, plugging the value of t. 10 times 1.25 minus 5 times 1.25, the whole square gives you 4.69 meters. So the two balls meet after a time 1.25 seconds later at a height of 4.69 meter. Numerical number 9. They wanted to derive a relation for distance traveled during the nth second of the journey. Nth second means the last second. For that, we use our normal equation S equals ut plus half at square. To get the displacement during n seconds, I am choosing t as n. And in place of ut, un, half at square, half an square. This gives you the total distance traveled during n seconds. Now, 1 second less distance traveled during n minus 1 second can be found by putting t equals n minus 1 in the same equation. So, in place of ut, un minus 1. In place of half at square, n minus 1 the whole square. That gives you this distance, which is the distance traveled during 1 second less, which is n minus 1 seconds. Math. U times n gives you un. U times 1 gives you u. Half a. N minus 1 the whole square becomes n square minus 2n plus 1. Then this remains the same. Half a into n square becomes half a n square. Half a into minus 2n gives you minus an. Half a into plus 1 gives you plus half a. We are looking for the distance traveled during, displacement in the last second, which is nth second. This is what we are looking for. This is written as Sn, which is S1, which is the distance traveled during n seconds. Take away S2, which is the distance traveled during n minus 1 seconds. So S1 minus S2. How much is S1? S1 is un plus half an square. And how much is S2? Un minus u plus half an square minus an plus a by 2. Next, this remains the same. Minus un. Minus and minus gives you plus u. Minus and plus gives you minus half an square. Minus and minus gives you plus an, minus and plus gives you minus a by 2. Un cancels, plus half an square minus half an square cancels. Remaining is u plus an minus half a. What I'm doing next is I'm just keeping 2 and 2 over there. I'm choosing a by 2 out. So u, a by 2 out. When a by 2 is out, this a and this 2 disappears, remaining one is 2n, a by 2 is out, remaining is 1. So this is the distance traveled or displacement during the last second, nth second of a uniformly accelerated motion. That's all. Thank you so much.